Hello friends, by now we all know what factor theorem is. If x minus a is a factor of the polynomial p of x, then p of a must be equal to 0. Now with the help of the factor theorem, let's solve a problem. So here is the problem. In this problem we have to check whether x minus 2 is a factor of the polynomial f of x. From the factor theorem we know that if x minus 2 is a factor of the polynomial f of x, then f of 2 must be equal to 0. So let's find f of 2. F of 2 will be equal to 2 squared minus 5 multiplied by 2 plus 6, which is nothing but 0. So f of 2 is equal to 0, which implies that x minus 2 is a factor of the polynomial f of x. In this problem, we were asked to check whether x minus 2 is a factor of the polynomial f of x or not. But what if we are asked just to find the factors of the polynomial f of x? Can we use factor theorem this time? Or is there any other method? In our earlier class, we learned how to factorize the quadratic polynomial by splitting the middle term. Let's go through it once. So, to factorize the quadratic polynomial x squared minus 5x plus 6, we split the middle term minus 5x as minus 2x minus 3x. Now, the polynomial is x squared minus 2x minus 3x plus 6. From the first two terms, we can take x common, and from the next two terms, we can take minus 3 common. Doing so, we get x into x minus 2 minus 3 into x minus 2. Again, taking x minus 2 common from both these terms, we get x minus 2 multiplied by x minus 3. So, we have factorized the quadratic polynomial x squared minus 5x plus 6 as x minus 2 multiplied by x minus 3. Now, let's see why this process actually works. So again, consider the quadratic polynomial x squared minus 5x plus 6. The first step is to multiply the coefficient of x squared and the constant term. So, their product will be 1 multiplied by 6, which is nothing but 6. Now, we have to represent this number 6 as the product of two integers. So, it can be either 1 multiplied by 6 or 2 multiplied by 3 or minus 1 multiplied by minus 6 or minus 2 multiplied by minus 3. Now, out of all these factors, we select those numbers whose sum is the coefficient of x. Here, we can see that the coefficient of x is minus 5. So, 1 plus 6 is 7, 2 plus 3 is 5, minus 1 plus minus 6 is minus 7, and minus 2 plus minus 3 is minus 5. So, the two numbers that we will select are minus 2 and minus 3. So, we will represent the coefficient of x, which is minus 5 in this case, as the sum of minus 2 and minus 3. Therefore, in the quadratic polynomial x squared minus 5x plus 6, we have expressed minus 5 as the sum of minus 2 and minus 3, and we split the middle term minus 5x as minus 2x minus 3x. That's how we split the middle term of any quadratic polynomial and factorize that quadratic polynomial. Now, here is a quadratic polynomial 11x squared plus 18x plus 7. Now, you try to find its factors. You may pause your screen and do this. Hope you got the right answer. Let me solve it so that you can check your answer. First, we will multiply the coefficient of x squared and the constant term. So, 11 multiplied by 7, which is nothing but 77. Now, we will express 77 as the product of two integers. So, it can be expressed in 4 ways. That is, 11 multiplied by 7, 1 multiplied by 77, minus 1 multiplied by minus 77, minus 11 multiplied by minus 7. Now, out of all these 4 pairs, which one we will consider? Yes, 11 and 7. Since 11 plus 7 is nothing but 18, which is the coefficient of x. So now, in this quadratic polynomial, we will split the middle term 18x as 11x plus 7x. So, the polynomial is 11x squared plus 11x plus 7x plus 7. So, from the first 2 terms, we take 11x common, and from the next 2 terms, we take 7 common. The expression will be 11x multiplied by x plus 1 plus 7 multiplied by x plus 1. Again, from both these 2 terms, if we take x plus 1 common, we get the final expression as 11x plus 7 multiplied by x plus 1. So, the factors of the quadratic polynomial 11x squared plus 18x plus 7 are 11x plus 7 and x plus 1. I hope you understood how to factorize a quadratic polynomial with the help of this method. There is another method as well. Let's learn even that method with the help of an example. Let's consider the polynomial x squared plus 6x plus 8. Let the factors be x plus a and x plus b. So, the product of x plus a and x plus b must be equal to x squared plus 6x plus 8, since x plus a and x plus b are the 2 factors of this polynomial. Now, you must be having a question. Why only 2 factors x plus a and x plus b? Why can't be more than 2 factors? If we had considered more than 2 factors, then product of those factors would result in a polynomial whose degree is more than 2. But here, the degree of the polynomial x squared plus 6x plus 8 is only 2. And that's the reason we have to consider only 2 factors but not more than 2 factors. Since we consider the factors of the polynomial x squared plus 6x plus 8 to be x plus a and x plus b, the product of x plus a and x plus b must be equal to x squared plus 6x plus 8. That is, x plus a multiplied by x plus b must be equals to x squared plus 6x plus 8, which implies that x squared plus x multiplied by a plus b plus ab equal to x squared plus 6x plus 8. From comparison, we can say that a plus b must be equal to 6 and ab must be equal to 8. Here comes the most important trick. Since a plus b is equal to 6, can we consider a to be equal to 3 plus k and b to be equal to 3 minus k? Yes, of course. Since 3 plus k plus 3 minus k is nothing but 6. But why did we use only 3? Since it is the half of 6. So a equal to 3 plus k and b equal to 3 minus k. Now, from ab equal to 8, we can conclude that 3 plus k multiplied by 3 minus k equal to 8, which implies that 9 minus k squared equal to 8 and k squared equal to 1. If k squared is equal to 1, then k will be equal to either 1 or minus 1. If we consider k to be 1, then a will be equal to 4 and b will be equal to 2, and thereby the factors will be x plus 4 and x plus 2. If we consider k to be equal to minus 1, then a will be equal to 2 and b will be equal to 4, and again thereby the factors will be x plus 4 and x plus 2. So here we can clearly see that no matter what the value of k we consider, the factors will always be x plus 4 and x plus 2. So the factors of this quadratic polynomial x squared plus 6 plus 8 are x plus 4 and x plus 2. The most important step in solving this problem was expressing the coefficient of x, which is nothing but 6, as the sum of 3 plus k and 3 minus k. That was the main logic. Now, using the same method, let's factorize another quadratic polynomial 6x squared plus 17x plus 5. But here you must be having a slight confusion. Since the coefficient of x squared is not equal to 1, we cannot express this polynomial as the product of x plus a and x plus b. So what should we do now? In the polynomial 6x squared plus 17x plus 5, we can clearly see that the coefficient of x squared is not equal to 1. So let's make it 1. And how do we do it? We simply take 6 common from all the terms of the polynomial. So the polynomial will be 6 multiplied by x squared plus 17 by 6 multiplied by x plus 5 by 6. Now this polynomial is of the form 6 multiplied by x plus a multiplied by x plus b. We know that 6 multiplied by x plus a multiplied by x plus b is nothing but 6 multiplied by x squared plus x multiplied by a plus b plus ab. Now by comparison we can say that a plus b is equal to 17 by 6 and ab is equal to 5 by 6. Since a plus b is equal to 17 by 6, we will consider a to be equal to 17 by 12 plus k and b to be equal to 17 by 12 minus k. Now from ab equal to 5 by 6, we will get 17 by 12 plus k multiplied by 17 by 12 minus k equal to 5 by 6, which is nothing but 289 by 144 minus k squared equal to 5 by 6. Finally, solving 289 by 144 minus k squared equal to 5 by 6, we will get the value of k to be equal to either 13 by 12 or minus 13 by 12. So the value of a will be 5 by 2 and the value of b will be 1 by 3. So the quadratic polynomial 6x squared plus 17x plus 5 is equal to 6 multiplied by x plus 5 by 2 multiplied by x plus 1 by 3. So in this problem, the two most important steps are taking 6 common from all the terms of the polynomial, and the second important step is expressing the coefficient of x, which is 17 by 6, as the sum of 17 by 12 plus k and 17 by 12 minus k. So friends, that's all for today. I hope you understood how to factorize a quadratic polynomial by both these methods. In our next video, we will learn how to factorize a cubic polynomial by making use of factor theorem. Till then, keep practicing and stay tuned.